Good day. Today we're going to be looking at exponential applications. That is growth and decay. Now, there are two types of compounding we're going to be looking at, discrete and continuous. Discrete compounding is of the form A being your total amount is equal to your principal amount times 1 plus or minus the rate divided by the number of times per unit t to the n times t being time power. Continuous compounding is A is equal to P times E. This is the irrational number E, that is not a variable, to the power of the rate times time. Let's try this. A substance decays 22% each day. After 7 days, there are 9 milligrams of the substance remaining. How many milligrams were there initially? For this problem, I want you to notice nowhere in it does it say the word continuous. Therefore, we're using the discrete compounding. A, P, R, N, and T are the letters that I want. A is the total final amount. So in this case, it is 9 milligrams. Here is my A. My principal amount is the initial, and that's what it's asking. So I don't know what my principal amount is. I'm going to put a question mark beside of it. My rate is 22% each day, so this is 0.22. The each day portion is my n. My n is equal to 1 because of each day. And my time is 7 days. Okay, now let's set up the formula. A is equal to P times 1 plus or minus my rate over my number of times n times t. Now for the plus or minus, which one do I want to use? Well, for that, I am looking at this word decays. Decays means I'm going to be using the minus symbol. So 9 equals, I don't know P, I'm going to leave it as P. 1 minus my rate, 0.22, over my n, which is 1, to the power of 1 times t. I'm going to divide by that set of parentheses because the P is connected through multiplication. P is equal to 9 divided by 1 minus 0.22 over 1. I'm just going to put this as 0.78 because that is what it simplifies to, and to save room. So 0.78 to the power of t, which is 7. Okay. Since I have this equation, I can type that in Desmos. Nine divided by 0.78 to the power of 7. And I get 51.2365. So I'm going to say this is approximately 51 point, it does not tell me what to round to. A general rule of thumb is 3 decimal places. That is a good approximation. So 0.237 milligrams of substance. Okay, that problem is finished. Let's move on. Sam opened a bank account with an interest rate of 4.8% that is compounded annually. So I'm using my discrete compounding formula. He invested $3,890 in 1999, but had to make withdrawal in his account in 2007, in the amount of $2,300 without penalty. How much money is in his account now in 2016? So for this problem, I'm going to need two formulas. Because in 2007, a withdrawal happened. So A of 2007 is what I need to find first. Because I know my principal amount in 1999 is $3,890. I know my rate of growth is 0.048. For my n, this says it is compounded annually, so n is equal to 1. This changes nothing, so I'm going to not include n in the formula. Since it is 1, it is not changing anything. My time is 2007, which is the year something happens, the withdrawal. And I'm taking the distance between that and 1999, which is 8 years. A is equal to, and again, this is A of 2007, 3,890, times 1 plus 0. I'm going to rewrite that because that looks strange. 1 plus 0.048 to the 8th power, not 7. 8th power. I'm going to type this in Desmos. And I get $5,660 in 2007. Approximately equal to and 31 cents. Now, I want to find the final amount of money in 2016. Well, I know my principal amount in 2007 is going to be the $5,660.61 and 31 cents. Minus my withdrawal amount, which is $2,300. This is $3,360 and 31 cents. My rate is staying the same, 0.048. My time is the distance between 2016 and 2007, which is 9 years. So my amount in 2016 is equal to 3360.61 31 times 1.048 There is apparently a dead zone in my iPad that I need to write around. To the power of 9. I'm going to leave that bottom one there for a different problem, so just keep that in mind. 3360.31 times 1.048 to the power of 9. I get in 2016, I have $5,124 and 26 cents. The next question says, how much more money would Sam have now in his account in 2016 if he hadn't needed to make the withdrawal? So this is my complete amount in 2016 with my initial investment of $3,890 at the rate 0.048, and my time is 2016 minus 1999, so 17 years. Putting this into my formula. And I get the amount in 2016 would be $8,631.60. It says how much more money would he have though. So I'm going to take my number, $8,631.60, and I'm going to subtract the $5,124.26. You can use Desmos if you need to, but this is $3,527 and 34 cents more if he had not needed to make the investment or make the withdrawal. Okay, pause the video, and as your assignment today, I want you to try these problems on the second sheet. That is all I have for you. Have a great rest of your day.